Welcome to the second part of this video from foodproductiondaily.com with me, Rory Harrington. Today I'm joined by Anne Roulin, Global Head of Packaging and Design, to talk about bioplastics. Now Anne, bioplastics are a big part of what Nestle is doing in terms of research. Can you tell us about some of the collaborations that you're involved with?
Well, we have a whole series of collaborations, some of them with universities, some of them are with big polymer suppliers, and others with start-up companies and other technology providers.
Okay. And in terms of outputs or projected outputs, what can you tell us?
Well, we really see this whole area of bioplastics as three generations. The first generation was materials like PLA, polylactic acid, or PHA, and these have certain applications, but they don't have the properties required for mainstream packaging applications, particularly the moisture vapor barrier to protect dry products. So whereas we use them, their application is limited. What is coming on stream now is conventional plastics made from renewable resources. For example, Braskem have just come on stream with their polyethylene, which is derived from sugarcane. And this is very interesting because polyethylene is a material that has been optimized for packaging applications for around 50 years. PET is also available partially from renewable resources, and work is going on to have 100% renewable PET. And polypropylene will be also on stream in a few years. The third generation will come from completely non-food sources. Materials like waste products, possibly algae, drought-resistant plants, and cellulose. And again, we see this will be the conventional plastics produced from these sources. It's a major challenge, particularly the degradation of cellulose, because in fact one of the oldest bioplastics is cellophane, which comes from cellulose. But it takes so much energy to break down the cellulose to make cellophane, the environmental impact is actually high. So doing this in an energy efficient way is under intensive investigation by a number of companies.
And in terms of, I've heard the date 2015 as being a watershed for Nestle in terms of some of these developments. Can you give us some insight into that?
Well, it's going to take at least this long to have the third generation, probably even longer. So we're really looking forward and working actively in partnership with suppliers in order to get there. Because we need these materials available on a big scale. It's not just lab production. We need huge production plants to be constructed.
And in terms of development of some of these innovative bioplastics made from non-food, is there anything to report about in terms of large-scale production in the pipeline there?
Well, there's companies like Total Petrochemical, for example, who are working on the base processes, for example, to go from methanol to olefins. And they have a big pilot plant in Belgium, and they've just started the construction of a 1 million ton plant in China. This first plant will be based on natural gas, because there is just not the raw material available to feed into a 1 million ton plant today, and the processes are not available. But the key part is going from methanol to the olefins, and that will be fully tested in this plant.
So has PLA reached the end of the line, or has it just reached a glass ceiling?
No, there is definitely still applications for PLA. It is a very interesting material. We use it in a number of applications, but the properties just don't fit the majority of our products.
And what about a fourth generation of materials?
Well, I think it's going to be an evolution where we will continuously reduce environmental impact, find more energy efficient processes. But I really see the trend going in the direction of conventional plastics from renewable resources.
Thank you so much for those insights, Anne. This has been Rory Harrington for foodproductiondaily.com at Nestle headquarters in Vevey, Switzerland.